Now here we are going to solve some of the very important sums based on integration by substitution. So first example we have taken integral under root 3 plus log x upon x. So as you see, the differential of 3 plus log x will be 1 upon x, because the differential of 3 is constant and differential of log x is 1 upon x. So let 3 plus log x is equal to t. So differentiating with respect to t, we get the differential of 3 is 0 and differential of log x is 1 upon x. So log 1 upon x dx is equal to dt. So our integration becomes integral 1 under root t dt, because here we have substituted 3 plus log x is equal to t, under root t we get, and 1 upon x dx is equal to dt. So ultimately we get integral under root t dt, which may also be written as t raised to the power half dt, and integral of t raised to the power half dt by the formula of x raised to the power n, we get t raised to the power half plus 1 upon half plus 1, that is t raised to the power 3 upon 2 upon 3 upon 2 plus c, or 2 upon 3 t raised to the power 3 by 2 plus c. And finally what we have to do, we have to substitute t is equal to 3 plus log x here, and we get 2 upon 3 log 3 plus log x raised to the power 3 by 2 plus c, and that's it. Now we have taken the second sum for explaining the integration by substitution. So this is very important sum. Here what we have to do, the sum is integral sine 2x upon a cos square x plus b sine square x dx, and here we let a cos square x plus b sine square x as t, though it is not quite clear to assume which function should be assumed as a second variable to get or to eliminate sine 2x from the numerator, or to simplify this integral. But you will have to remember, so differentiating this function with respect to t, what we get, a as it is constant coefficient, and differential of cos square x by chain rule 2 cos x into minus sin x. Next, plus b as constant coefficient and differential of sin square x by chain rule 2 sin x into cos x, and dx is equal to dt. So as you see, this is minus a into 2 sin x cos x, and this is b 2 sin x cos x dx is equal to dt. So as you see, by sin 2 theta formula is as sin 2 theta is equal to 2 sin theta into cos theta, 2 sin x cos x becomes sin 2x in both the terms. So what we get minus a sin 2x plus b sin 2x dx is equal to dt. So we may write it as, taking sin 2x common out of it, we may write it as b minus a. We have written b first because this is positive, and then minus a. So sin 2x dx is equal to dt. Now transposing b minus a to right hand side, we get sin 2x dx is equal to 1 upon b minus a dt. So by this substitution, finally we have, our integration becomes integral 1 upon, this is t as we have assumed, this is equal to t, so 1 upon t, and rest is sin 2x dx. Sin 2x dx and sin 2x dx we have by this substitution, that is 1 upon b minus a dt. So write down 1 upon b minus a dt. Since 1 upon b minus a is constants, we may take it out of integration. So 1 upon b minus a और integral में क्या रह जाता है now 1 upon t dt. As you know, 1 upon b minus a as it is, and as you know the integral of 1 upon t is log mod t plus c. C is the constant of integration, and finally we have to write the value of t which we have assumed in the beginning. So 1 upon b minus a log mod t is a cos square x plus b sine square x plus c. And now the next question, next sum, we have taken integral 1 minus tan x upon 1 plus tan x. So what we have to do here, first of all, we have to break tan in terms of sine and cos. Sine upon cos, as tan theta is equal to sine theta upon cos theta. 1 plus in the denominator as well, sine x upon cos x dx. And as you see, taking LCM, and as you see, taking LCM here in the numerator cos x, we get cos x minus sin x. In the same way, in the denominator, taking LCM cos x, we get in the numerator cos x plus sin x dx. Now here denominators are cancelled in numerator and denominator. LCM in the numerator is cancelled by the LCM in the denominator, and ultimately we get integral cos x minus sin x upon, and cos x plus sin x in the denominator, and we may write it as sin x plus cos x because addition is commutative. So rearranging them in that way, it is quite clear that differential coefficient of sin x plus cos x will be cos x minus sin x, because differential of sin x is cos x and differential of cos x is minus sin x. So here we let sin x plus cos x as is t, and now differentiating with respect to t, we get cos x minus sin x dx is equal to dt. So our original integration becomes here, this is we have assumed as t, so we get 1 upon t, and this is equal to dt. So simply we are left with integral 1 upon t dt, whose integral is quite simple, log mod t plus c. And finally we have to substitute the value of t here, and t we have assumed as sin x plus cos x. So sin x plus cos x plus c, and that's it. Now we have taken some tricky sums. So here you see, check it. What is the differential coefficient of x e raised to power x? So let's check it. X as it is, by product rule, first function as it is, differential of the second one is the same, and then plus, and differential of first one is 1, and second function as it is. If you take e raised to the power x common out of it, we get in the bracket x plus 1, or x plus 1 and plus 1 plus x is the same thing. So what we have in the numerator, exactly the same expressions. That means the differential coefficient of x e raised to power x is exactly x1 plus x. So simply we have to assume x e raised to the power x as theta, and differentiating with respect to theta, we get x e raised to the power x plus e raised to the power x dx is equal to d theta, and taking e raised to the power x common out of it, we get e raised to the power x, x plus 1 dx is equal to d theta. So our integral becomes integral, and this becomes exactly equal to d theta, and this is we have assumed as theta. So simply we have 1 upon cos square theta d theta, And as the reciprocal of cos is sec, so 1 upon cos square becomes sec square theta d theta, and integral of sec square theta is tan theta, as you know well. So tan theta plus c. Now we have to write tan theta in terms of x, because our original variable in the given integral is x. So what we have to do, we have to write theta is equal to e raised to the power x from our assumption, and we get tan bracket x e raised to the power x plus c. That's it. But if you like to write this result in algebraic form, so what we have to do from here, we have to find out the value of tan theta, that is tan theta will be equal to x raised to the power 4 if tan inverse x raised to the power 4 is equal to theta, and then we'll have to make the triangle of angle theta, and according to tan theta is equal to x raised to power 4, the perpendicular is x raised to power 4 and base is 1, and by Pythagoras theorem we may write it as 1 plus x raised to the power 8. So if we find cos theta from this triangle, cos theta is based upon hypotenuse, so we have to write minus 1 upon 4 cos theta, that is 1 upon under root 1 plus x raised to the power 8 plus c, or simply minus 1 upon 4 under root 1 plus x raised to the power 8 plus c. So in this way you may write this result as this.